So what we're going to do, just this introduction, we're going to talk about multiplying binomials. Okay, so a binomial is just an algebraic phrase that has two terms in it. Okay, so nomial means term, and the prefix bi means two. Okay, so when multiplying binomials, it says it's simply using the distributive property. It says, however, the process is done two times. So multiplying everything in the first set of parentheses by every term in the second set of parentheses. Okay. Now you guys, if you go back to maybe some Algebra 1 stuff, you've heard the word FOIL before, correct? You heard that before? Yeah. Okay. FOIL is a phrase that allows us to remember what we're multiplying. Okay. But if you think about foiling, so F, when we FOIL, stands for first times first, right? Okay. So you're going to take the first term here, and you're going to multiply it by the first term there. So A times M is just AM. Okay. So we took first times first. I like to draw arrows here like this. Then O was outside times outside. So if we think about these four things standing in like a row, A and N would be your outside terms, right? They're the ones on the edge. They're the extreme ones. So we take A times N, and we get positive AN. Okay? Now, here's my question. Does that, with those arrows, does that look like I distributed A to that second set of parentheses? Yeah. Okay. Now, when we do I stands for inside times inside. Well, those are your two middle terms then. B times M. I get BM. Okay. And then L stands for last times last. So the last term in the first set of parentheses times the last term in the second set of parentheses. So we get B times N, which is just BN. Does that look like we just foiled, or not foiled, distributed B to that second set of parentheses? That kind of makes sense? So you're going to hear me, FOIL is fine. FOIL is a phrase that you guys are accustomed to, you use, and you'll hear me say it, but I like to use the phrase distribute everything from the first set of parentheses to everything in a second set of parentheses, okay? Because what happens then is eventually when you guys get further into things, and we might get to this point at some point in the year, where I might want to multiply like x plus 3 times like x squared plus 3x plus 5. Now FOIL doesn't work, because FOIL only works if it's two things times two things, right? Okay? But the way that I do that, the way I do that multiplication is I distribute the x and the x plus 3 parentheses. I multiply that by everything that's in the second set of parentheses. And then I take the 3 that's in that first set of parentheses, and I distribute it to the second set of parentheses. And that's how I do it. And it's exactly the same way that we do a binomial times a binomial. If I want to do a trinomial times a trinomial, maybe 5 terms times 12 terms, whatever it may be, you take this term here and you distribute it to everything there. Then you take this term here and you distribute it to everything there. And then you add like terms together. Okay, so that's the same route that we use with FOIL. But FOIL only, that term only works for two things. Okay, two things times two things. Here's an example using numerical values. We could do this two different ways. But let's, it says do it before simplifying, and then after simplifying, are your answers the same? So let's show that this actually works, this procedure works. If I were to do this using just standard techniques, that would be, if we go with like order of operations, combining like terms, that kind of stuff, that would give me 5, correct? That gives you 9, correct? And they're being stuck together through multiplication, so what's that give me? Gives me 45, correct? 5 times 9? Okay? Let's do this problem using FOIL. Let's go 3 plus 2, and we're going to multiply that by 5 plus 4. Okay? So what I want to do, I'm going to FOIL, or I'm going to take that 3 right there, and we'll distribute to both those things. Okay? So what's 3 times 5? 15. What's 3 times 4? 12. Okay? So that was distributing that first part. Now let's distribute the second part. Let's take that plus 2 and multiply it by those two things. So what's 2 times 5? 10. What's 2 times 4? 8. So now what's 15 plus 12? 27. Plus 10 would be 37. Plus another 8. Same 45, correct? Does that demonstrate to you that when we do this foiling or distributive property, that it generates something that is true? Okay, I know this should be 100% should be 45 using other techniques. We use this current technique, I still get the same 45. So because those are equal, these two techniques must be equal. Okay, and what's nice about recognizing this is that eventually, when I replace some of these values in here with variables, instead of 3, instead of 2 and 5 and 4, this technique disappears. I'm not able to use that. But this technique will still be present, and we can use it. Okay? So the idea is down here. Okay? So it says this process usually involves variable terms like this one. Okay? So remember what x represents. X represents just a number. So if x was like 2, this 2x would actually be 4, so we'd have 4 plus 4. And this 3x would be 6, so we'd have 6 minus 7. Okay? But we could then, do those two procedures we did in the previous example. But because we don't necessarily know what x is, I just randomly chose 2, x is really representing all numbers that we could ever possibly choose. So we want to develop a rule that allows us to determine what this is going to look like with the x's in there. Okay? So what we're going to do is we're going to take 2x times 3x. So what's 2 times 2? Or sorry, 2 times 3? 6. Does anybody know what x times x is? Or remember what x times x is? What's your best guess? X squared. Good. Okay? So when you multiply variables that are the same, so in this case, x and x, you add their exponents. Okay? So because this exponent is a 1 right there, and that exponent right there is a 1,